The next method which follows the steepest descent is conjugate gradient method. It's also called Fletcher-Reeves method. Conjugate gradient method, also called Fletcher-Reeves method. It's more or less similar to the steepest descent method which we have solved. In the previous class, we have solved the steepest descent method. How we have solved the steepest descent method? We have followed the algorithm. Mostly similar to the algorithm of the conjugate gradient method. Only difference lies in estimating the S2 value. I tell you, just open the steepest descent method, open steepest descent and check the number of times. Just open steepest descent method. See, you started with one initial point. This is common. Check it. You started with an initial point. Maybe x suffix 1, maybe prefix 1. It depends on the author. Okay. So you start with the initial one. Then what you have done? You have estimated the gradient. You have estimated the gradient. You have estimated del of x1. Fine. How you have estimated del of f1? Dou f by dou x1, dou f by dou x2. So you have estimated, and you have kept minus sign. In steepest descent also we have kept minus sign because we want steepest descent, not ascent. So we took minus sign. So that means such direction is common from the steepest descent to this method. Then what is the third one? You have estimated x2 using x1 plus s1. Using x2 is equal to x1 plus lambda 1 star s1. How we estimated lambda 1 star? Optimum step length. How we estimated? You have taken f of x1 plus lambda s1 with respect to lambda 1 derivative equal to 0, get lambda 1 star. You estimated. So similar line till getting x2 is common. Now what you have done after getting x2? You have estimated del f2. Fine. If del f2 is 0, you have stopped there itself. Process is closed. It's steepest descent. Fine. And then if it is not, how you have proceeded? You have proceeded again. S2. Del of S2, that is minus of del of F2. And then using that you have estimated again lambda 2 star. That is difference now here. You won't go for lambda 2 star. Till lambda 1 star the process is same. We won't go for lambda 2 star. Instead what you do is we will change S2. S2 is equal to, what is S1 initially? Minus del F1. But now S2 is equal to del F1. See, if I want S2, del F2 whole square by del F1 whole square into S1. If you want S2, use S1 information, use del F2 information. Then you estimate S2. Then use S2, same process. Again then estimate lambda 1 star, that is lambda 2 star. Because here you are now changing the S2 direction also. So little bit complex compared to the steepest descent method. Then again we will check for the optimality. That is if del f of that particular x2 value or x3 value is gradient is 0, we stop the process. Otherwise we will meet further. We will go to xi plus 1 and start with that step number 1 again. Note down first. See, these algorithms are little bit tedious until and unless we need to go step by step, understand and then attempt. Completely note down so that we will start the problem. Okay. Now know the problem. Minimize f of x1 comma x2. Minimize f of x1 comma x2 is equal to x1 minus x2 plus 2x1 square plus 2x1 x2 plus x2 square. Given initial point x1 is equal to 0, 0. Starting from the point, so it has given the initial point. Starting from the point x1 is equal to 0, 0. I took almost the same problem what I had done for the steepest descent, so that it will be bit easier because we already attempted the steepest descent method. Fine. So let us start with iteration 1. So what is iteration 1? Because you know the initial point, estimate del f1 and keep minus sign to get s1. Okay, initial x1 is equal to 0, 0. Now need to find del f x1. That is dou f by dou x1, dou f by dou x2. At x1, x2, the initial value. So what is dou f by dou x1? What is the function? So what is dou f by dou x1? Yeah, 1 dou f by dou x1 is 1 plus 4x1 plus 2x2 minus 1 2x1 plus 2x2. Now keep the value of x1 as 0, 0. That is x1 as 0, x2 as 0. You will get 1 minus 1. So that your S1 is minus of that one. That means minus 1 and then 1. Step number 2 is over. So you have estimated first S1. So this is now iteration 1 we are starting. Iteration 1. Now after S1, what you have to do? After S1, what you have to do? Same like step the steepest descent. We need to find out the lambda star first. So f of x1 plus lambda 1 s1 with respect to lambda 1 should be equal to 0. Then only we will get lambda 1 star. Now find out lambda 1 star. So what is x1 plus lambda s1? x1 is 0, 0 plus lambda 1 times s1. What is s1? Minus 1, 1. Minus 1, 1. Okay, so what is now? It will be minus lambda 1. Lambda 1. 0 plus lambda 1 into minus 1. That is minus lambda 1. 0 plus lambda 1 into 1 is lambda 1. Now you substitute minus lambda 1 and lambda 1 in the equation and differentiate with respect to lambda 1 equated to 0 to get lambda 1 star. So if I substitute, I will get, see, lambda 1 square minus 2 lambda 1. This I will get. If I differentiate with respect to d lambda 1 and if I equate to 0, I will get lambda 1 star is equal to 1. Let us create till step number 3 now. Step number 2, S1. How you estimate S1? Taken the del F, substituted the x1 value, you got 1 minus 1. Take negative sign so that S1 is minus del F1. So you will get minus 1, 1. Then step number 3 is estimating the lambda 1 star. How to estimate lambda 1 star? F of x1 plus lambda s1, you need to take differentiate with respect to lambda 1. Now what is x1 plus lambda s1? x1 is 0, 0 because initially x1 is 0, 0 plus lambda 1 into s1 is minus 1, 1. That means you got minus lambda 1, lambda 1. That means substitute x1 as minus lambda 1, x2 as lambda 1 in this equation and take derivative with respect to lambda 1. If I substitute what I will get if I substitute here? I got lambda 1 square minus 2 lambda. If I differentiate and equal to 0, I will get lambda 1 square as 1. Now I have to substitute in the third step, lambda 1 star. Now you tell me what is x2? If I substitute the lambda 1 star, what is x2? x2 is equal to x1 plus lambda 1 star, that is 1 into s1 is minus 1, 1. So what is x1? Initially x1 is 0, 0. Now what is your x2? What is your x2? Minus 1, 1. Now find del f2. Del f2. So if del f2 is 0, then you can stop. Already what we have done for the steepest descent. Whenever the next iteration point gradient becomes 0, you can stop the process. But if we estimate del f2, that is keep x2 value in the del f. Are you getting 0? If not, we have to go to the next step. Optimal step length, optimum if you reach, we can stop. But del f2 is not 0. What is del f2? If you substitute, x2, so del f2, how much you got del f2? Del f2 is minus 1, minus 1. Del f2 is minus 1, minus 1. So it is not 0. Del f2 is not 0. Then come to the next steps, very crucial steps. Listen carefully. Estimation of the next steps becomes crucial. Listen carefully. Because del f2 is not 0, we need to estimate s2. After estimating s2 only, we have to estimate lambda star. So what is the difference from the previous step to this step is, in previous method, we are just estimating the lambda 1 star every time. S2 will be always del f2, del fx. For example, if I want S1, del fx1. If I S2, del f2. If I S3, del fx3. S4, del fx3 in the previous method. But here, only first time S1 is del f1. For the next time, S2 will be this equation. From every time after first iteration, your S is changing. Your S is function of some other del f's, not single del f. So that's the only difference from the previous method to this method. In the previous method, only your lambda star every time you need to calculate and substitute in this equation. Go for every iteration, find out del f, if 0, stop there. But in this method, only one time your S1 is del f, but the second time it is this equation. Now estimate S2. S2 is equal to minus del f2 plus del f2 whole square by del f1 whole square into s1. I just substituted in this equation. because I want 2. So substituting I as 2, del of 2 whole square by del of 1 into S1. Now what is del of 1 in the previous one? Del of 1 is 1 minus 1. Del of 1 is 1 minus 1, del of 2 is minus 1 minus 1. Now just check the formula here. Here they are used the mod. Mod of del of 2. What do you mean by mod? So even if the negative is there, it will become positive. So del of 1 will become 1 1 because even is minus, it will become 1. Del of 2 minus 1 1. So mod del of 2 will become 1 1. Similarly, mod del of 1 will become 1 1. Now whole square. How to calculate whole square? Whole square is nothing but squares of the individual one. Square plus square. Similarly, square plus square. Del of square means individual element squares. So now substitute here. Minus del of 2 minus of minus 1 plus 2 by 2 into minus 1 1. Your S1 is minus 1 1. Your del of 2 is minus 1 minus 1. Your del of 2 whole square is 2. Your del of 1 whole square is 2. Now what will be final S2 value? 0 2. 0 2. S2 is equal to minus del of 2 plus del of 2 whole square by del of 1 whole square into S1. S1 is this one. Del of 2 whole square just now we have calculated. Del of 1 whole square just now we have calculated. Substituted, and after simplification you will get S2 is equal to 0 2. Now the same thing. We need to now find out lambda 2 star now. After estimating S2, f of x2 plus lambda 2 star into S2 with respect to lambda 2 need to 0 so that lambda 2 star will be calculated. Fine. Now what is x2 plus lambda 2 S2? What is x2? x2 is minus 1 1 plus lambda 2 times S2 is 0 2. Now tell me what is the answer? x2 plus lambda 2 S2. You will get minus 1. You will get 1 plus 2 lambda 2. x2 plus lambda 2 S2. x2 plus lambda 2 S2. You will get minus 1 plus 1 plus 2 lambda 2. Now we have to substitute minus 1 plus 1 plus 2 lambda 2 in the function differentiate with respect to lambda 2 equal to 0 to get lambda 2 star. I am giving the answer. So if you substitute, you will get d of 8 lambda 2 minus 2 with respect to lambda 2 equal to 0. You will get lambda 2 star as 1 by 4. See here lot of points of confusion. బాగా చూడండి బోర్డు కాసి ఇక్కడ చాలా కన్ఫ్యూజన్ ఉంటుంది. You will get lot of confusions in estimating the next value of x2, in estimating the next value of x2, in estimating the next value of lambda 2. But if you properly follow the steps, there will not be any confusion. I have started with initial point x1. Just estimated the s1 one time only using del of x1. You know del of. So substitute x1 value to get s1 by keeping the negative sign. Keep it aside. The next step is estimation of lambda 1 star. How we will estimate lambda 1 star? Use x1 value and differentiate with respect to lambda 1, get lambda 1 star. And after getting the lambda 1 star, substitute here to get x2 value. So till this point, whatever your steepest descent, this method will be same. But from next step, it will differ. Because when you estimate del of at x2, it won't be 0. If it is 0, you can stop. If it won't be 0, what you have to do? You have to go to the next step. When you go to the next step, your s changes. In earlier method, your s is only this one. If I want s3, substitute x3, so that del of 3 will be s3. But here not like that. Your s3 will become del of 3 plus del of 3 mod whole square by del of 2 mod whole square into s2. So your s2 changes, your lambda changes every iteration. See in the second iteration, this first iteration, second iteration what I have done? I have calculated s2, then I have calculated x2 plus lambda 2 star s2 to get lambda 2 star. Two values are estimated in iteration number 2, s2, lambda 2 star. Till this point clear, iteration number 2. Now what I have to do, after estimating lambda 2 star, I need to get x3. What is x3? x3 is equal to x2 plus lambda 2 star into s2. x2 is minus 1 plus lambda 2 star is 1 by 4 into s2 is, what is s2? 0, 2. Now find out what is x3. Minus 1? That is 1.5. So you will get minus 1, 1.5. Now x3 is calculated. Now calculate del of x3. If it is 0, stop there. Del of x3. You can stop. Del of x3. If you calculate, when the gradient becomes 0, you can stop the process. So just 2 iterations, you are getting the optimum. Just 2 iterations. For example, if del of x3 is not 0, then what you have to do? You have to calculate s3 now, because s2 is over. You have to calculate s3. s3 is equal to del of 3 plus del of 3 whole square by del of 2 whole square into s2. Is it okay? Is it okay? Any doubt? ఏమా కాంజుగేట్ చూడండి, నేను ఆల్రెడీ చెప్పాను యూనిట్ 3 నుంచి వచ్చే మెథడ్స్ అన్నీ కాంప్లెక్సిటీ ఉంటుంది. అందుకోసం మీ లెవెల్కి ఎంత అర్థమవుతుందో ఆ మెథడ్స్ మాత్రమే నేను క్లాస్లో చెప్తున్నాను. మిగతావి హై అండ్ అన్నీ వదిలేస్తున్నాను, ఎందుకంటే అవి నేర్చుకొని కూడా మీరు ఇంప్లిమెంట్ చేయలేరు. టైం లెంత్ ప్రాసెస్ ఎక్కువ. మీరు ఒకవేళ స్ట్రక్ అయినా మీరు సొల్యూషన్ మీకు రాదు, షార్ట్ కట్ మీకు తెలియదు. సో అవి చెప్పడం కన్నా కరెక్ట్గా మీకు లోపలికి ఏమవుతుంది, ఎగ్జామ్కి కరెక్ట్గా ఏమి రీచ్ అవుతారో అవి మాత్రమే నేను మెథడ్స్ ఎక్స్ప్లెయిన్ చేస్తున్నాను. ఇవి కూడా మీరు నేర్చుకోకపోతే నేనేం చేయలేను. బికాస్ ఈ ప్రాసెస్ మీకు హిమాలయంలో కానీ ఇంకెక్కడ కానీ దొరకదు. ఇవి నేను రాసి ఇంప్లిమెంట్ చేసి కోడింగ్ రాసి సాల్వ్ చేసిన మెథడ్స్ ఇవి. సో దట్ ఆల్గరిథం ఈజీగా ఉంటుంది. కొంచెం స్టెప్ బై స్టెప్ ఫాలో అయితే మీకు ఈజీగా మీరు ఫైండ్ అవుట్ చేయగలుగుతారు ఆప్షన్. ఓకే. సో 2 ఐటరేషన్స్ లో ప్రాబ్లం వచ్చేసింది. నాకు తెలిసి ఎగ్జాంపుల్ 2 ఐటరేషన్స్ కూడా ఇవ్వడు, ఎందుకంటే ఇట్ ఇన్వాల్వ్స్ when the function is simpler one. ఇందాక నేను ఇచ్చినట్లుగా x1 మైనస్ x2 సింపుల్ వన్ ఇస్తే ఒక 2 ఐటరేషన్స్ కి ఒక హాఫ్ అన్ అవర్ పడుతుంది అనుకుందాం. అదే కనుక కొంచెం ఫంక్షన్ ఎక్కువ ఇచ్చాడు అనుకోండి, దాని ఒక ఐటరేషన్ కి టైం పడుతుంది హాఫ్ అన్ అవర్. సో ఒక్కొక్కసారి ఏం చేస్తాడు, ప్రీవియస్ ఇయర్ కాకుండా అంతకు ముందు ఇయర్ ఆల్రెడీ ఒకటే రాయమన్నాడు, ఇది ఒకటే రాయమన్నాడు, ప్రాబ్లం కూడా ఇవ్వలేదు. సో ఒక్కొక్కసారి అలా కూడా జరుగుతుంటుంది. సో ఏదైనా సరే మనం నేర్చుకుంటే అటెంప్ట్ చేయగలుగుతాం, నేర్చుకోకపోతే ఏం లేదు. సో స్టీపెస్ట్ డిసెంట్ కి కాంజుగేట్ బ్రేక్ మెథడ్ కి సిమిలారిటీ చెప్పాను క్లారిటీగా. ఎక్కడ వేరీ అవుతుందంటే ఫస్ట్ ఐటరేషన్ S1 వరకు బాగానే ఉంటుంది, S2 మారిపోతుంది. నో లెట్ us come to the న్యూటన్ మెథడ్. this is called Newton method. Don't confuse with Newton-Raphson method, which you have solved in the previous unit. Newton-Raphson method is for unconstrained single variable automation technique. Okay, now we are doing multivariable automation techniques. Here, this method is proposed by Newton, where he is using again the such directions, but the such directions involve second gradient of the functions, that is del squares. Now look at the algorithm. So again the algorithm starts with initial point. Similarly, what you have done, finding the gradient, same thing which you have done for the previous method also. Earlier the gradient del f, but here given some name called small g, whichever may be the same, and take the negative sign. Same thing we have done. So s1 is minus del f1. Instead of del f1, he has given a name called small g. So S7 is equal to 0. Now till this point, the previous method and this method and whatever the steepest descent method all are same. Next method will vary. Here we won't get any lambda stars. We won't get any optimum step lengths. Instead what we calculate is square of del f's. Second gradients, del square f. So this del square f is named as capital G. We will estimate del square f. That is dou square f by dou x1 square, dou square f by dou x1 x2, dou square f by dou x2 x1, dou square f by dou x2 square. We will find out the inverse. We will find out the inverse of this matrix. That's called G inverse. Then the optimal step length is optimum point. How to estimate optimum point is x2 is equal to x1 plus whatever minus this small g. This minus small g multiplied by this capital G inverse. So this capital G inverse into small g, whatever small g, that is S1, we call in the previous method. So we do follow the same thing, only the difference is we try to estimate for every iterations this del square of inverse. Okay, fine. And then again, after estimating x2, we will go for the del f. If the del f is 0, you stop there itself. Otherwise, move back. Again calculate s2. Again calculate g inverse. And then again calculate x3. It will move ahead. Put on no problem. F of x1 comma x2 is equal to f of x1 comma x2 is equal to x1 minus x2 plus 2x1 square plus 2x1 x2 plus x2 square. Take initial point x1 as 0 0. Solve by Newton's method. Solve by Newton's method. So let's go step by step. So what is the initial point given? x1. x1 is equal to 0 0. Now find out small g, which is del f by dou x1. So small g1. Same thing, 1 plus 4x1 plus 2x2 minus 1 plus same functions I am taking because I already done this one. So what is g1? that is keeping x1 in the del f, you will get 1 minus 1. Is it not? Now find out capital G. What is capital G? Dou square f by dou x1 square, the same thing. Dou square f by dou x1 square, dou square f by dou x1 x2, dou square f by dou x2 x1, dou square f by dou x2 square. And if you substitute in these the x1 value, you will get g1. Tell me what is the value of g1? So is it almost nothing but your Hessian matrix? We have done for the unit number 1. We have done Hessian matrix also we have done. So what is the value now? Tell me. 4, 2, 2. So capital G is now calculated. Now find out capital G inverse. Capital G inverse. Capital G inverse. 1 by 2 minus 1 by 2 minus 1 by 2 1. Inverse of this matrix. 1 by AD minus BC into DAB minus C. You know that. Finding the inverse. Switch it over. Find the inverse of the G matrix. Because we want G inverse. Because what is the formula for next one? x2 is equal to, here what is the formula? x2 is equal to x1 plus G inverse into small g. This is the formula now. So now what is x2? x2 is equal to x1 is 0, 0. So plus what is G? 1 by 2 minus 1 by 2 minus 1 by 2 1 into G is minus of G is what? Small g is what? 1 minus 1. So 1 minus 1 is minus n. So you will get minus 1 plus 1. So you tell me what is the answer for x2? Sir, answer. Please cover. So tell me what is x2? Why not x2? G inverse into small g. You have already calculated small g. So minus of small g, minus 1, 1. Minus 1, 1. Multiply with g inverse. So you tell me what is the answer? Add x1. What is the answer for x2? What is the answer? Minus 1? Correct. So you will get minus 1, 3 by 2. Now x2 is calculated. Then directly straight away calculate del of x2. If your del of x2 becomes 0, stop there itself. Find out del of 2. Del of 2. Del of 2. Del of 2 is 0. That means your process is ended. So only one iteration. Understood now? Newton's method only complication is lies with calculating the G inverse, capital G inverse. Because many people fail to calculate the inverse part. Nothing else. So this problem only one iteration given in the end exam. Only one iteration. See, you see, after estimating x2, your del f2 becomes 0. So what is the problem here in this method? Calculating the G inverse part. What is capital G? Hessian matrix. Dou square f by dou x1 square, dou square f by dou x1 x2, dou square f by dou x2 x1, dou square f by dou x2 square. Calculate that inverse part. Multiply with small g. Small g is nothing but minus del f. Add to x1, you will get x2. Find out del f x2. If it is 0, stop there. If not, you are going to go to the next iteration. Okay? Just check with another problem. Do it for another problem. F of x is equal to to 4x1 square plus x2 square minus 2x1 x2. Given initial x of 1 is equal to 1, 1. Do it now. Newton's method. Newton's method. Solve by Newton's method. Do it. Do everyone. Calculate small g, calculate capital G, calculate G inverse, calculate x2. Do everyone. x1 given. Find out small g. Small g is, what is small g? Del f1. That is dou f by dou x1. Dou by dou x2. Calculate capital G. Dou f by dou x1. What is dou f by dou x1? 8x1 minus 2x2. Dou f by dou x2 is 2x2 minus 2x1. Now substitute x1 value. You get del of 1, 6. Yeah, that is small g. So negative of del of is small g. Keep it aside. Calculate capital G. Calculate capital G. 8 minus 2. 8 minus 2. Minus 2. 2 or 4? 8 minus 2 minus 2, 2. Now find out inverse. Find out inverse. equals 1 by 6, 1 by 6, 1 by 6, 2 by 3. Now calculate x2. Now find out x2. x2 is x2 will become 0 0. So if it is 0 0, what is del of x2? There ends your problem. So only thing is only one iteration. You look at the problem. Many of these complex problems they will ask for to do either only one or two iterations. So take some time and step by step if you go you can solve. Okay. univariate method. It's a line search method. It's a line search method. What we do in this line search method is we start with the one search direction. We try to fix constant all the other variables. Then we will move forward by taking the step length in that direction, and then we try to estimate the next point. And then what we do in the next iteration, we take the other direction and keeping the other variables constant, and then we will same thing we will go ahead until and unless we will get the optimum. Solve the function f of x1 comma x2 is equal to 10 minus 2 into 1 minus x1 whole square minus of 1 minus x2 whole square using univariate method. Using univariate method with starting point x of 0 is equal to 0, 0. So in this method, we start with one direction, keeping other directions constant, other variables constant. We try to find out the optimal step length moving in that direction. Then we move to the next direction, keeping the earlier directions constant, and we will go ahead. Okay? Just solve this problem using univariate. He has given one starting point. Okay? So remember step number 2, when you are moving in that direction, we need to take this step length into account in that direction. We need to take into step length in the direction. So that when you are taking the step length means we need to optimize the step length. That is, we need to estimate the lambda star. So when we are taking the step length, we need to optimize. The same thing which I have done for the previous case. Okay, let us enter into the problem so that you can come to know. So what is the function given? F of x1, x2 is equal to 10 minus 2 into 1 minus x1 whole square minus 1 minus x2 whole square. So f of x1 of 0 plus lambda 1 comma x2 of 0. I am moving in x1 such direction. Is it correct now? I am moving in x1 such direction. That means I am keeping x2 as constant. I am not touching x2. Only moving in the x1 direction, so I am taking the step length into account. So initially x1 plus step length, x2 is constant because the methodology of univariate search method says when you are moving in x1 direction, keep x2 constant. So I have not touched any x2. As it is, x2 is kept like that. But x1 I have added this step length because I am moving in the x1 direction. Now what is x1 0, x2 0 initially has given? 0, 0. What is x of 0? 0, 0. That means x1 is 0, x2 is 0. So f of 0 plus lambda 1 comma x2 is 0. So f of lambda 1 0. Now you take differentiation with respect to lambda 1. Equate to 0. Get lambda 1 star. Optimal step length, because when you are moving in this direction, you need to find out the step length. Do it now. Substitute lambda 1 in the equation what is given in the function. Maybe you will get the equation as f of 9 minus 2 into 1 minus lambda 1 whole square. This you will get, you differentiate with respect to lambda 1, d lambda 1, if I am differentiating with respect to lambda 1 equal to 0. Just check whether you are getting this or not. Substituting x1 as lambda 1, x2 as 0. Substitute x1 as lambda 1, x2 as 0. Are you getting this equation or not? Check. So take derivative with respect to lambda 1. You will get lambda 1 star as 1. Now what is my x1 now? Because initially x1. Now what is my x1? x1 is equal to x1 0 plus lambda 1. Lambda 1 is 1. So 0 plus lambda 1 is 1. And x2 is 0 only because I have not touched anything, 0. So my next iteration value x1 is 1 0. See, initially x0 is given. How have I estimated x1? x1 is whatever the step length I took, keeping x2 constant. Step length I took lambda 1, which I got as 1. So initially it is 0 plus 1, 1, and this will be 0 only. But this is my next iteration value. Now one direction I have gone through. Now I am moving in another direction. x2 such direction. x2 such direction. So what is my x2 such direction? f of x1 comma x2 of 1 plus lambda 2. See here, I am moving in x2 direction. So x2 plus take another step length. Keep x1 constant, but take the reset value because x1 you got now. Don't start again with 0 because you have started with 0, you have reached to some new point. Take that point. But move in x2 direction. Keep x1 constant. Is it clear or not? See, what is this and what is this? Be clear. First time you are moving in x1 such direction. So only add step length to the x1. Keep x2 constant. I am not adding here any x2 here. Just look at it. Because I am moving in x1 such direction. With this, I have estimated lambda 1. Now, if I know lambda 1, substitute here to get the next value. Now, after getting this x1, start new such direction, x2. So, when you are moving in x2, add step length in x2 only, keep x1 constant. I have not added here lambda, here only I added lambda. But I took the recent value because x1 I had got. I again did not start with 0 because I started with 0 and I ended up with x1. Now what is this value? X of 1. What is x of 1? X of 1 is 1, comma x of 2. That is 0 plus lambda 2. Now you substitute this in the function and differentiate with respect to lambda 2 to get lambda 2 star. That is 1 lambda 2. If you substitute, what is the equation you will get? Approximately you will get 10 minus of 1 minus lambda 2 whole square. This you will get expression. To differentiate with respect to lambda 2, you will get lambda 2 star as 1. Now if lambda 2 star is 1, what is x2? x2 is equal to, see, x1, that is 1. And x2 plus lambda 2, x2, 0 plus lambda 2 is 1. So you will get 1. So the x2 is now 1, 1. The x2 is 1, 1. Now start with again such direction x1. x1 such direction start. Then already ఒకటి చేశాను ఇప్పుడు మీరు చేయండి ఒకటి. x1 such direction లో చేసి lambda 3 star కట్టండి. కట్ చెప్పండి ఎంతో. x1 such direction చేయండి ఇప్పుడు. ఈ పాయింట్ తీసుకోవాలి. x2 పాయింట్ తీసుకొని x1 such direction లో వెళ్ళాలి కదా. చేయండి. take reset value of x2, go in x1 such direction. What is the expression? If I move in x1 direction, what is the expression f of x1 of 2 plus lambda 1 comma x2 of 2. అంతే కదా x1 డైరెక్షన్ లో మూవ్ అవ్వాలంటే x2 కాన్స్టెంట్ పెట్టాలి. రీసెంట్ వాల్యూస్ ఆఫ్ 2 తీసుకోవాలి. సో ఏం అవ్వాలి? f of x1 of 2 సెకండ్ ఇటరేషన్ వాల్యూ ప్లస్ lambda maybe 3, maybe అనుకోండి 3 కామా x2 అలాగే ఉంచండి. ఆ ఎక్స్ప్రెషన్ ఏమొస్తుందో చెప్పండి. Yes, 10 minus. Very good. 10 minus 2 lambda 3 square. Now differentiate with respect to lambda 3 equal to 0 to get lambda 3 star. 0. Yes, very good. 0. Now what is x3? x3. Very good. 1 1. So x of 3 you got 1 1. Now you start using x3 in x2 such direction. Using x3, start x2 such direction. Now x1 such direction is over. Now use x3 value to move in x2 such direction. x of 3 1 1 వచ్చిందా? x of 3 1 1 వచ్చిందా? After getting x of 3, move in x2 such direction. Yes, if you move in x2 such direction also, you will get 1 1. Finally, x4 equal to 1 1. So that shows whether you move in x1 such direction or if you move in x2 such direction, you will end up with the optimal point as 1 1. That's all. This is called univariate search method. Start with one direction, keep the other one constant. Now move in another direction, keep the previous one constant. Find out the step lengths. it okay? Fine. So I am stopping here unit number 3 at this point because the other two